Hey all, my name is Maciej. I'm an Airflow and OpenLineage committer, and thanks to my astronomer, I'm able to be on Airflow Summit third time and talk to you about how we integrate those two projects. And maybe start with the agenda. This won't be an OpenLineage intro talk. I won't tell you everything about it, but I will tell you what it is. Maybe why should you care? And then I will talk a bit about current OpenLineage Airflow integration that is in Airflow 2.7 plus. Then I will go what we recently have done it, and maybe a bit about the plans for the future. So let's start. What's data lineage? So data lineage is basically a set of relationships between jobs, data sets, and you can visualize it as a graph. Basically, every data set has some kind of producer, maybe some consumers, and not every, but some jobs produce data and read data. And why should you care? Basically, it allows you to have a view of relationships of data in your organization. Another very important thing is security and compliance. There has been a lot of issues regarding data leaks. One particular one was that some bank has leaked data for a vendor because they weren't even aware that they are sending some kind of data to the vendor. And also a very common one is sending production data to development environment where it's accessible by everyone, regardless of controls that might be in the production development. So when I saw this graph before, it looked like a few nice views, but in reality, it looks like one of those old Airflow graph views, and it's extremely chaotic. And especially with the kind of data tools that we now have and use, there is more and more problems with having a coherent view about data in the organization. And that's why we've created OpenLineage, which is basically an open standard how to describe the collection, creation, lineage from pipelines as they're running. And we are LFNAI in data graduate project. We're open source. You can go to OpenLineage GitHub page and see all the code there. And basically the idea is to connect all the producers of lineage. So all the schedulers, warehouses, SQL engines to the possible consumers of lineage. So data governance tools, data observability. And so the idea is to have the common standards between those. And why do we capture data, want to capture data in runtime? It's because you can try to deduce the location in this photo where it was taken by the image itself, right? And try to capture some metadata, looking where's the sun, what's the possible hour of day, what's the type of stuff there, but you can also capture the EXIF data in the photo. And then you have complete information about data, about date and location when it's captured. You're trying to do kind of the same for data. Rather than look at query logs, look at some other external information or manual annotation. The data tools know what data are they consuming and what they've written. So they should share the data with the rest of the ecosystem. And the best way to do this is by working with an open standard. And the project has been growing. We've been having much more integrations. There are metadata producers, metadata consumers, and one of the newest is Trino integration, which was fully contributed by the community members. And we have a lot of consumers. Lastly, we've seen Amazon Data Zone consuming OpenLineage events. So the community has been growing. And we also have seen contributions by multiple organizations, such as Astronomer, Data, Microsoft, and much more. So you don't have to look much further. For example, a tool that uses OpenLineage, and that's AstroObserve, recently announced, which allows you to see the lineage graph, the flow of data in your organization, and another stuff like SLAs, and it's powered by OpenLineage. Let's take a look at how the Airflow integrates with OpenLineage. So maybe first let's look at what it does, right? So we have some very simple graph. It's using the deprecated Snowflake operator. It's not very complex. Insert some data, and we enable OpenLineage, pointed it to Marquez, which is like open source reference implementation of OpenLineage consumer, and we see, well, we have a job, and it produces some data set. That's basically what we want to achieve. How does it work? So in 2.7 Airflow, we contributed AP53, which is basically two-part implementation of how do we capture the metadata. So part of those is actual instrumentation of operators. So each operator, as you can see in this example, BigQuery to GCS operator, can have different methods on it, such as get OpenLineage facets on complete, start, and those methods basically produce an object called operator lineage describing the lineage. So here we can see like BigQuery, so we know, and it's bugged on this slide, the BigQuery object that we're reading is some kind of table that's identified by project ID, dataset ID, and table ID. And we output the location where it's being written to by this BigQuery to GCS operator. We can implement this for every operator in Airflow, where it makes sense, of course, because there are some operators when it doesn't make sense, such as, I don't know, Slack API operator. There's a lot of them. Like there's hundreds, if not thousands of operators, also including custom operators. And that's one part of it. And second is Airflow has something called listener API that lets the listeners know when the task starts, completes, fails, and the same for DAG, and the same for datasets, Airflow datasets. So those listeners run on worker, and before and after task runs, Airflow is calling them, and it's part of the OpenLineage provider, the OpenLineage listener, and basically what it does is checks if those methods exist on the operator. If the methods exist, that it means that the operator implements OpenLineage, and we call them. Then the data captured by it is enriched by some common Airflow facets, so like the information when the basically task started, and that you don't have to embed this in your OpenLineage implementation. And there's more of the description in last year's presentation. I've linked it, but you can also go to OpenLineage Airflow Summit YouTube channel and look at it. I describe it there on more details. There you can check a look at supported operators on the Apache Airflow documentations. We have got a list there, it's automatically generated. And the operator is there, then it produces some data. But, okay, should we end this presentation? Is this enough? Well, no, it's not. So the Airflow survey indicates that people still want more data lineage, and it's the second most popular request. And also, like, let's see, so how people do use Airflow, right? I asked the most, known knowledge database right now, what operators people use, what should we implement, and we seen that the first one is PythonOperator. And if we talk about this, think about this model that I presented with PythonOperator, it doesn't work, right? Because you can't answer generically for every Python operator what lineage will it produce, which you can with some other operators, right? Because every Python operator uses different Python callable, and one might write data to Snowflake, and second might read data from S3. That's not something you can do this way. So, and also, like, there's other ways to work with Python as a custom code. And this is TaskFlow API, which is introduced in Airflow 2.0, so very well spread right now. It allows you to eliminate the boilerplate with writing Python operator, and basically underneath it converts the Python operator in a way. But also another very popular way. And another thing that was introduced recently in Airflow is object storage, which allows you to read the data from the different file-like storages, S3, GCS, and other object storage without like having to use a lot of code. So we basically can treat it as a path. And it's an example of object storage usage, which it reads data from some kind of S3 bucket. So like, well, let's look what happens if you run something like this. And this is like object storage. Dagnus uses object storage in Airflow 2.9. And we run it and we just see there's a job, right? There's no lineage. Okay, that sucks. So problem is arbitrary code, right? People love writing their own code. There are some non-code operators that generally know what they do. We can instrument them in the way. But the code operators can be anything. There are custom operators, and there are way more ways to write your own code in Airflow. So is there anything we can do? Turns out we can instrument the hooks. So let's take a look at what are actually hooks. So the hook is Airflow mechanism for basically communicating with arbitrary external system. Operators that tend to do anything useful tend to use hooks because the actual integration is often contained there. This one is I think, GCS copy, method on GCS copy. It basically copies data from bucket to bucket, right? And you can use this directly in your code, copy the data, and OpenLineage won't know anything about it. So how would we instrument them? And we can't do the full approach that we use in operators, which is have a method, have the hook define the lineage that we have, just because there's a lot of methods on hooks, right? One is copy, one is write to. There's a lot of stuff that one hook can do. It basically defines the whole interaction with some external systems. But what we can do is we can push it from the instrumented method. What we've done, we've added hook lineage collector on worker that has some add input dataset, add output dataset methods. And those methods basically accept some arguments that we can use to construct the compliant dataset later. What it means, I will do in a minute, but you can see the implementation here. It's readable for somebody from the further side, but basically the method in hook can call some API that allows you to register the dataset they are writing and reading from. And the hooks already know that, right? Because the S3 hook is used to write data and read data from S3. So it's pretty obvious that they know where they write data to. And for object storage, we can do very similar thing, which is to wrap the file object it uses and track the reads and writes across the usage. And there's no additional instrumentation needed for S3 and GCS, just because the object storage treats it all as a file and uses the URI to describe the modified object, let's say. Well, maybe you can say I don't care about this. I have some Python operators, I have other stuff, but it only works, I don't care. This is unnecessary overhead for me. But it only works if you use it. It's not actually OpenLineage specific. You can write your own plugin, register it via plugin mechanism, and use the gathered lineage for your own purposes. The OpenLineage is maybe not reference implementation, but the one that we provide in OpenLineage provider. And if there are no readers, then basically this data gets discarded. And how we understand those data sets. Basically, there is an AP60 that was contributed by TP Chunk that basically defines the standard on how Airflow datasets should be named, which is S3, colon, semicolon, I don't remember which one is it, what's the name in English of this object, and then 2 slashes, right, and then bucket name and the path, right? So what we do is the providers, other providers like Amazon provider or GCP provider or some SQL provider owns those data sets, right? So the Amazon provider owns the S3 schema. It knows how to sanitize the URI, how to convert it to OpenLineage, and how would we create this data set from random plugs. So the translation between those two formats is pretty much obvious for us. And let's look at the same DAG in 2.10, and this is now producing data set. So exactly what we want to achieve. Yeah, and also this doesn't matter whether you use Python operator, TaskFlow, custom operators, or even some operators that don't have the implementation yet. All of those can gather data from hooks and manipulator. It's just they have to use hooks. And there is, of course, one pretty big caveat, and it has to be the same process as worker. So if you have a Kubernetes operator job or, I don't know, even Python virtual env operator job, it won't work. at least now, maybe we find a solution for this later. There's nothing that prevents us, but it doesn't work right now. It has to be the same process as the general worker. So let's take maybe a look, peek into the future. So what we will do in Airflow 3. One thing is that we talk about datasets, Airflow datasets, and this will change. Basically, this will be assets now. We, as an OpenLineage, will try to, with this change, address one, well, pretty useful case, which is like not everything can be detected still with hooks, because, I don't know, maybe you have your own hook, it's not instrumented, or like there's no own instrumentation yet. Basically, we want to try advantage of the assets that are annotated by this mechanism. So if you define your like data-aware scheduling, you can use it for this. You will also get like the whole package, which is lineage in our case. Second one, and yeah, so if you use those, you can see that you have a lot of synergy between different things in Airflow. So if you're using like hooks, assets, hooks with connection underneath, and at the end you get lineage from those. So using the stuff that's built in into Airflow gives you an advantage over like writing your own connection system, secret management, not plugging it into standard Airflow mechanism, because you will not be able to benefit from this. All makes more sense together. And there is an additional AP72, so I show this like graph, how this works. And it's not how it's going to be working in the future, because the worker won't have direct access to the database. So we will have to rework the integration, but it will have one advantage, which is that we can emit those events asynchronously later. So this won't block a worker slot when we are emitting the event after it finishes. So basically we'll pay slightly less, maybe not noticeably less, but slightly less either way. Second is the isolated execution. So if we're not running on worker, then we can't crash worker in reason some bug happens. And additionally, we think of like enriching the data more with some asynchronous execution, like asking the source database more about the dataset. The one drawback of this is that contributing this operator implementation might get more complex, because you have to define two things separately. One of those is the part on the worker and the part that's doing the synchronous emitting. Thank you.